Hello back, everyone. I hope you got to take a little break. I would like to encourage you to take breaks when you can, because sitting in front of Zoom can be tiring for extended periods of time. So I always like to, after 1 hour or 2 hours, just to get up and stretch a little bit, grab some water, and that can give us more energy to keep going. Before we start with our case, with the coding portion of our case, I would like to answer a question that I saw on the chart that I thought it was very interesting. Excuse me. Somebody was asking, what is the difference between the mean and the expected value, which is a very good question. The expected value is a mathematical concept that refers to a theoretical distribution. Let's say, what is the expected value of a family distribution like the normal distribution. However, the mean is actually a feature that is actually measured. So the expected value is the value that you would expect to observe if you would sample, if you would get a given sample from a particular distribution. So let me share my screen now. Can you all see it? So there are also a lot of appreciation for the music that was played during the break, and I think it was an excellent choice. I noticed a lot of songs that were typical from the 80s, so there were many good songs. I usually like to play songs and music while you work on exercises. However, the case that today we had was like so full that we had to go at a faster pace. But I'm thinking that starting on Saturday, I will play also some of my music while I assign some of the exercises. In previous editions of this class, the students really appreciated some music during the class. So we'll teach while we play some music, okay? Now, in the last 30 minutes of today's meeting, we are going to take a look at the coding portion. And so we are going to see how to replicate some of the plots, the tables, and the calculations that we have performed in the cases by using, of course, Python. So the first step that we want to do in order to perform the basic feature engineering is to let's start importing pandas. Pandas is the set of suites, that is features and functions that we are going to be using the most. There will be other ones that we will be using. One of them is actually called matplotlib, which is a library that Python can use for plotting. Again, there are other libraries that can be used by Python, but these are the ones that we are going to be using because they are reasonably simple, okay? The module that we will focus on is called the pyplot, and we can import it in this way. So from the matplotlib library, we will load the pyplot module as PLT. PLT is an alias. That means that instead of typing pyplot, we can just call it PLT, which is quicker and more simple for coding, okay? So first thing that we did was feature engineering, creating new features because the data was not organized in the format. We did not have all the variables that we want. So we worked on transforming some of the existing variables by creating new ones. So first of all, we need to read the data set. The data set, we said, is saved in CSV format, and it's called d.csv. And the command that we're going to use is pd.read _csv. This command allows us to import the data set and store it with the name capital D, okay? Not to be confused with the capital D that we had for the Dominion stocks, okay? Some of you might be having some issues with the coding and importing and so on. The TAs will help you debugging this after our class today, so it might be more useful if it's, if it's taking too long, just focus on the class, and then you can use the text of the case to go back and revisit these problems. Okay, so if we want to display the first rows of a data set, we use the command head. It's the same thing in R, by the way. If you do head of D, it will show you by default the first 6 rows. Here in Python, you can also select how many rows you want to display. So d.head 10 will display the first 10 rows of the data set. Okay. The first column that you see here, okay, is actually an index. The index that is listing the rows one by one, and it starts at 0 by default. Other softwares like R start at 1. Okay, but what can be done, what a lot of people like to do sometimes, is to use one of the variables as the index itself. Now, in this case, since we have a time index data, the date can be selected as the index itself. Okay, so the command set _ index can allow you to select the feature or the variable that you want as your index. In this case, date. Okay. Now, this will alter the original data frame. And now, if you replicate the same command d.head 10, you will see that now the index, the previous index disappeared, and the new index is the date. Okay. So what we wanted to do was also to assign to each row the symbol of the stock. Okay. And we have a file for each one of the stocks, of the stocks types. We have one for the UK, for EXC and EE, and so on, right? And again, there is always a difference between the symbol that you are going to have in the data set and the name of the data set itself. That's what we call D before, but was not to be confounded with the value that we are going to be putting on the different rows. Okay, so we are going to import all the other data sets, right? And using the same acronym that we have for their abbreviation for their name. Now, if I want to create a new column, okay, we can use the following syntax. We create a new column, give it a name, for instance, volatility or returns or whatever you want, and then specify how you're going to calculate this new column. Okay. So if we want a symbol for each one of the rows of the Dominion data set and add D, we can do D. Remember, D was the name of the data frame. Then we can, this is the name of the new column, and this is what we are going to enter for each one of the columns. In this case, it's only one value, so it's simple, right? And notice that now if we plot, if you display the first 10 rows of the data set, we see that the new column with the symbol D has appeared. And we can do the same thing for all the other data sets. So we can put as a symbol the UK, EXC, NE, and SO. And then we can put them together and create just one concatenation of all these data sets into a data frame. The command pd.concat will allow us to create a new data set with, is called generically stocks, that has put together all the different files, and to tell which stock they belong to, we create the variable symbol that will be indicating the stock that we are considering on that specific row. How do we calculate the return? To calculate the returns, we remember that the formula was the closing price at time t divided by the closing price at time t minus 1, so at the previous time, minus 1, okay? So if we want to just calculate the return for July 3rd, we have to select the close of July 2nd and the close of July 3rd, and then calculate the return of July 3rd. So you take the ratio of the first two numbers that you have defined minus 1, and then you can print it, and indeed you have this value. You could do this by do a for loop and so on, and then but it would be really unpractical. So the best way is to create a new column that indicates the closing price for the previous day by using the shift function. So the shift function takes a column and shifts it up or down depending on your input. Okay. We can shift the series so that the value associated with July 3rd is no longer its own, but is rather the one corresponding to the previous one. Sorry, to the following one, which would be July 7th, right? Remember that 4, 5, and 6, the markets were closed. And in this case, we have the next day, right? But if instead we want to shift up and go and take the previous one, if we want to bring the series downward, then we specify shift 1, okay? And then we can also shift by 2 days, by 3 days, and so on. And basically, the command shift allows us to look at the next values of the column or at the previous values of the column, depending on how you want to organize the data. Josh says, how can I create a column in another position, not the last one? Well, the default is that the new column gets added last, but there is a way to actually shuffle the indexes of the columns and move them around. So it's actually not super hard. We might see a case where we can reorganize this, but it's not really crucial because we want to in the end, what we are interested in is in the content of the column and not in the absolute position in the data set. So we do not want to do this one by one, of course. We want to create one column once and for all in a rapid way. So if we want to create a column of the closing price at the previous day, remember what we had defined is first of all, we need to create a new column, and we can call it close previous. And then we select the close column, which was given on the original data set, and apply the shift. Since we want the previous day, we do shift, and in parentheses, we write the number 1. If we wanted the closing price of the next day, we would put -1 on the shift, okay? So now we add a column. Remember, on the first observation, we have not a number just because there is no observation on the day before, but it's not a big deal. And notice that this value here, okay, is equal to this value here. So, and the next value, 61.730, which is the closing day, the closing price the previous day, we can find it as here. Okay, so notice that the column has just been shifted downwards. Now that we have the two columns that we need, remember, we needed to take the ratio between the closing price today and the closing price yesterday, or the previous day. I like to say today and yesterday, but it's for any generic day and the previous one. We take the ratio of these two columns. So we take dclose divided by dclose previous minus 1. Very simple. And we save it as the return. So the return can be, of course, positive or negative, depending on if the closing price at the current day is higher or lower compared to the previous day. If I want to, remember, we were a little bit uncomfortable with the volume variable in number of shares. And we said, well, the number is very large. We might want to consider millions of shares. So we might divide by 1 million. And to calculate a ratio, we have already seen it here. The slash symbol indicates division. Luis says, what happens if we put 1 instead of 1.0? Nothing. Python would be okay with that. Dorian is asking, why are you doing over D and not over stock variables? That's the way, just the way the case was written here, just for illustrative purposes. But indeed, we will have to do it for the entire stock data set, so we consider all the other ones. All right, that's a very good question and very good. And now we are going to remember that the returns, we ended up not using it to compare the volatility. So it was done only for the D data set, but for the volume that we ended up using, so if we want the volume in millions, we'll take the volume, we divide by 1 million in the stocks data frame that we had created, okay? So let's go ahead now and let's calculate the volatility. So the reason to put the parentheses here, somebody, I saw a very quick question appearing, that why are we putting the parentheses? Well, it's because, for instance, in this case, we need the parentheses because we are considering the numerator is stocks high minus stocks low divided by stock open. So we want to make it sure that they are correctly, we are dividing, otherwise only the second value would be considered. So now we're creating a new column, which we're gonna call vol stat. And we defined it as the difference between the highest price and the lowest price on that day divided by the opening price. Okay, so now we have the data set with all the variables that we need, and we can go ahead and see some of the syntax for the histograms. We started with the histogram for the volume in millions. And the command in Python to display a histogram is plot.hist. And the parentheses that are open and closed here, it means that there you can put arguments for that function to personalize your histogram and the way that is defined. Some of the options that you can change are the title. So if you call your histogram, and this is his HVM, stands for histogram volume million. Set title will allow you to select the title, in this case, histogram of volume millions. Set underscore X label is the millions of shares. And then PLT, remember the PLT was the alias that we defined the plot lib, and dot plot, and we display the histogram. Okay, so very simple. Now, as an exercise, if you want to plot the open column in stocks, you create a histogram object for the opening. You can call it HO. And you add a title, you add the next axis label, and then you plot it. So very, very simple, very straightforward. If you go to the help file, you will find different ways that you can personalize the histograms, from the choice of color, from the choice of labels, the size of the bins, if you want absolute frequencies versus relative frequencies, if you want a larger space on the y-axis, you can change all sorts of functions and arguments within the same function. So how do we calculate the summary statistics in Python? Well, a lot of them have a very intuitive syntax. So for instance, if I want to calculate the highest value, max is the syntax. Minimum, min. For the mean, median, and mode, they are all very straightforward. And you have basically to define them with a dot. then the name of the function that you want to apply, and then in parentheses, you will have to indicate the variable for which you want to calculate the under square brackets, the value of the name of the variable that you want to calculate that particular summary statistics. Okay. Thank you to Mauricio that is sharing a reference for the PyData. And so if we want to calculate the minimum, we select the variable close, which is the variable that we are considering right now, and the dot min will give me the value, the minimum value of the closing. Notice that here we are considering all the stocks. So by reporting this minimum here, we do not know which one of the different firms are we considering here, which one of the energy stocks we are considering, okay? If I want to calculate a quantile, okay, the extension that you need to use is dot quantile, and then you have to indicate the percentage. So if you want to calculate the 30th percentile or the 30th quantile, as you want to call it, you can put 0.3, which means 30 divided by 100, which is 30%, and it will give you the 30th percentile for the particular for that particular variable. If we are interested in the quartiles, so the 25th, 50, and 75%, we can just do quantile 0, quantile 0.25, quantile 0.50, 0.75, and 1. And then we can print them. If we save them as object, let's say 0th percentile, a 25th percentile, etc., then we can print them, and we have these five numbers that represent the values of interest. Okay. We can easily calculate for any column all the summary statistics or the most relevant summary statistics by using the extension .describe. Remember, these are also called descriptive statistics because they describe the data set. This is not inferential statistics. We are not doing inference about this data. We are just describing them with quantitative summaries. So for instance, if I want the relevant summary statistics for volume in millions, I add the extension .describe, and we have, first of all, the count, how many observations we have. 4,250 observations. We have the mean, we have the standard deviation, we have the minimum, the other quartiles, and the maximum. Also, we have some other information like the name and the type. This is the data type float 64. It means that is a floating number at 64 bits. That's more like a computer science kind of question, and it denotes the precision of the way that the data are actually saved. So these are saved using the maximum number of the architecture of the computers that we are using right now, which is 64 bits. Okay, so they are saved in long format. So if we do this, we are looking at the summary statistics at a glance for all the variables, right? But it would be more interesting to decouple them for each one of the stocks that we are considering. So if we group them by symbol, okay, by using the group by function, we can represent the summary statistics or the median or the mean and so on by symbol. For instance, if I want to know the median of each one of the stocks, okay, I will do stocks.group by symbol. So this is the grouping variable. The first argument will be the grouping variable. The second argument will be the actual column that you want to summarize. And then the third one would be the variable, the statistics that you want to calculate, in this case, the median. So by symbol, the median will be 0.01 for Dominion and so on and so forth. And this is just the median for the volume in, okay, for the volatility, sorry. This is the volatility if we want it for the volume, we will have to just specify here the volume, okay? Copy the preceding code and modify to run the described function on the grouped vol stat column. And well, that's pretty much the same. And except that instead of just reporting the median by symbol, we are reporting the entire table of summary statistics. Remember, .describe is going to give you all the summary, all the descriptive statistics. And you get this beautiful table. Notice that with just one command in Python, you can get an effective table that you can add to your reports that can help you summarizing the data a great deal. Always start with these basic steps before you venture into any other more advanced commands or models and so on. So here, notice that we are using a lot of commands, and I know that this will take a bit to metabolize, but you will have, is conceptually not hard. So we want stocks. What is stocks? Stocks is the name of the data frame. Group by, it means that we are grouping by what? By symbol. What are we grouping? The vol stat column. Once we group them, what do we want to do with them? We want to describe them. We add .describe, and we have the table with all the descriptive statistics that, remember, are the number of observations, mean, standard deviation, minimum, first quartile, second quartile, which is the median, third quartile, and the maximum. And then, if we want to plot the time series to investigate the features of the volatility, we can look at the stock index, which is the date, remember, but you want to save it in a way. You want to say, right now the date is simply an index, but you want to save it in such a way that is a date and that can be interpreted by Python as a date time, okay? So what you do is stocks index, you do PD to date time of the stock index, and then it becomes a date time index. That helps tremendously when you're plotting. So Python is not interpreting the first column as just a categorical variable, but knows that it's actually a variable that is ordered by date, okay? And you might want at this point to plot the different volatilities for the different stocks by applying what we have learned. If we want to plot by stock, we use the extension .group by. So we are grouping by symbol. We are plotting the vol stat variable, and automatically the index, since it's saved as a date, will be on the x-axis. And notice that you have a time series plot that contains 5 different time series, one for each one of the stocks. Notice that Python automatically assigns a different color for each one of the series. It might not be the color that you want. There are ways to personalize this. And in the plot, remember I told you that those parentheses indicate the space where you can add some of the options. Well, for instance, if you want to add the legend, you can specify legend equal to true, and Python will create a legend for you by default. Again, it can be modified. And then also you can select a title. So you do not need to enter necessarily a title separately, but you can do it directly inside the .plot function. And notice that now you have a legend that tells you which stock is associated to the different columns. Javier, is there any way to subplot to see the data in 5 different graphs? Absolutely. You will just have to basically select just one of the symbols and then just plot it just like you would plot just using the similar one. You might want to change the title and so on. Yeah, of course, that's possible. And probably would help with readability, right? Because you have a part of the graph here that is a little crowded. You cannot see it very well. So I would probably also like to see it separately in this case. But this is a more advanced way of putting everything together in a graph and so on. And for instance, for this plot, you cannot really see very well all 5 of them, but it's very useful for the other plot that we saw before, actually to have them together all on the same graph, right? And you can have actually fun trying to replicate the mean volatility by month of the year, although it's not in this portion of the case, but that can be, I'm sure that the TAs will go through it with you. And now this plot is somewhat tiny and it's hard to see, but it's perfectly okay to try to stretch the figure size, and the option fixed size allows you to change the dimension. So if, for instance, if you want the x-axis that is longer or bigger than the y-axis, you can put like a larger number, let's say 15 and then 6, okay? And it will give you like a more realistic time series plot. You can also see much better the colors. So remember that here we had the issue that they were not very readable. You can make it even a little bit larger. You can also make the lines a little bit thinner. So there are many different things that you can do to personalize the data and the options for the plot. And a lot of material today, but we managed to go through it and to finish exactly at 10 o'clock. Abram says perfect time. Well, years of practice.
Hey,
thank you all for your attention.
Thank you, Professor Gabino, for an amazing case. This is one of the best, well-done cases of correlation one.
Yes.
But right now, what we are going to do is on your TA channels, your TAs are going to post a Zoom link. Then please join your TA group's channels, and they are going to walk you deeper through the code and through the exercise. And also, I encourage you to code by yourself. This exercise is because you need to start to code to understand how these concepts can be implemented by coding. Then please join your TA channels. And thank you, Professor Gabino. See you.
Thank you all. Thank you for your energy so
Saturday.
late in the night. I really, really appreciate your desire to learn. Please keep learning with your TAs. They work very hard to help you and do the best they can. It was a pleasure, and I will see you very soon. Buenas noches.